when I sat back down, I realized I thought I had a pretty good handle on what are the common additional things you might want to do with the outputs from Freesurfer, and I realized, okay, actually there are a bunch more things that we should go over, and I don't have that done explicitly in detail, like how to do that. Freesurfer is the syntax you use for calling Freesurfer commands changes from one function to the next. So rather than speculate, I'm just going to leave that as a bit of a to-do. So there is more stuff that we can go over coming up for sure. But I think we can piece it together from code that Liz is using now and a bunch of stuff that Matthias is using, and so I think we have, like, after today, maybe one more real solid meeting about this, and we'll be all set. And I talked to Bobby, if you guys are interested down the line in a meeting where we discuss what I've skipped, which is what can go wrong with the recons and how do you fix them. So for your own use down the road, she's happy to go over that, and I'll sit in and talk to you.
Yeah.
Yeah, it can be, it can be illuminating. I mean, we're sort of spoiled. We mainly so far with our adults that we collect data from. We look at the kids' data. You can see some serious issues, and one of the things that we have not spent a lot of time doing is what we can do, like what we can do to improve the images before we even use Freesurfer. That's just been sort of like a time constraint trade-off. So that's something, if you become aware of the kinds of problems with the scans, maybe down the road, that's something we could look into in future work we're doing. Okay, so
but like, if we were working with structural data in the future, we would.
If you're going to use structural data, if you're going to do structural data analysis in the future, you would either, yes, you would want to learn that, like what you would want to learn that, and so I do think it's worth us going through that, and or find someone that has looked at a lot of these. So I think that's what a lot of or they just kind of ignore this stuff, which a lot of people know. I mean, if you're just doing this to generate ROIs, to do some sort of like ROI-based analysis, functional connectivity or contrast, functional bold contrast, that's probably not so bad. If you want to do morphometry, probably not a great idea. Is this recording?
Yes.
No? Okay, so I'm going to be flipping back and forth between this and the VNC window. So what I may try to do is just make this as big as I can, and still be able to get over that window. So just to So the plan for today is to just a refresher of what some of the main files are that we're interested in. We'll load up Freeview. We've already talked about Freeview a bit, and I think people are getting more familiar with it. But I just to show you, one of the things that we haven't done is just talk about some scripts that can make the whole thing a lot easier. And then we can jump to we can look at how those files load up. And then we can talk about the annotations and differences in the kind of commonly used annotation files that we'll have and how those are generated. So if you remember, there is you run recon all, you get the subjects directory, you have a, I'm sorry, you have a, a directory where all the subject recons go. They each have a name, and then with each one of those subject directories, you have this set of directories, and we are interested in these volume-based files here that are in the MRI directory, surface-based files that are in the SURF directory, and then in terms of brain-related files, we also will be creating labeled files, so our surface annotation files and labeled volumes and things like that. We talked a bunch last time about the scripts directory and files that are in there, which are essentially like log files of the process, and resources for you to look into to make sure that we ran without an error, and if there's an error, what the error might be. So let's say you want to now run Freeview. We went over this a bit, but I just wanted to go through. The last time we did this, it was unanimous that we wanted to just sort of piecemeal load everything in the GUI so that we don't have a good idea of where the files are and what the files are. And I think that's a very good idea. Would you like to do that again today, or would you like to just skip to, hey, here's a script that'll load up a bunch of stuff for you? You want to? Okay. So just to go through this command again, just before we get to the script, when you call Freeview, so as a reminder, actually, when you're running Freesurfer, you want to load the Freesurfer module, and if you right now in the SEC, if you use module load Freesurfer, it loads the most recent version of the most recent release of Freesurfer, version 6. And then there's a command Freeview. When you run Freeview, you can load volumes and surface files. And it used to be, actually, as recently as when I was first putting this together, it seemed like you needed to use a -V here to indicate volumes. You can still use that, and it's kind of nice to do that just from an organizational standpoint. So you know what comes after this are volume-related files, and -F is used to indicate surface-related files. So last slide I showed a bunch of the different files that we care about, and here we can there's a Freeview command to load all of these. And so first we'll load some volumes. There's a brain mass volume here, which is basically like it's a processed version of the T1 structural scan. That's the basis for all the Freesurfer processing. It's been processed a bit here, and the skull has been removed. There's a white matter volume, and then also a label volume. So we'll get to this in a bit, but you can load up the label, a volume that's in the same space as the original brain mass volume that had, instead of being the T1 scan, there's a label for every voxel that points to some region name. And you can also load up the surfaces, so peel surface, white matter surface, and inflated surface are all ones that you might want to look at. The syntax here is so for instance, you load up, say, a volume, colon, and then there's some flag, and then you give it a value. So you set a color map here for a volume, and you can set opacity. You can flip the scale. If you use this is a particular map, you can flip that scale. Same syntax for the surfaces here. Yep. Okay. Yep. That'll come up a bit, but I'm happy to go into
later. That's fine.
Yeah, it's so CTAB are color tables, and what makes this confusing is that, why don't we just talk about it now? What makes it confusing is that you have, when you do when we talk about Freesurfer, we're often thinking of those surfaces that are generated. Those surfaces are generated for the left hemisphere and the right hemisphere independently. And you have, let's say you have a precentral gyrus in the left hemisphere. You also have it in the right. Those are separate files though, so you can just have a precentral gyrus in one and a precentral gyrus in another. And what Freesurfer does for the annotation files, so the label, it's basically the labels of the surface. It embeds in that a color table that says, okay, if this vertex has this value, then that means that vertex is in precentral gyrus. Okay? And that same color table is used for the left hemisphere surface and the right hemisphere surface. So you have a precentral gyrus in the left and a precentral gyrus in the right. And those would have the same value. So let's say you're making a color table and you said, okay, index 3 is precentral gyrus. So in the annotation file for all the vertices that are in the precentral gyrus, it's going to have a label that's.
So how does it know that that's so you can right but other defaults like was it always
When you apply the annotation, so you can set it, you can change it, but the way that this works in terms of the normal progression for us is you create the surface, and then that surface is mapped to FS average template. There's a mapping that says, okay, this vertex in the individual maps to this vertex in the FS average surface. And we have an annotation, so that is basically a label that we assign to every vertex in the FS average surface. And what you can do then is say, okay, well, now I'm going to go back and go from that, where that vertex is in the template. I'm going to go for the corresponding one in the individual subject's surface, and I'm going to create an annotation file for your individual subject, where that vertex is given a value that is essentially or links to the name precentral gyrus.
okay. So let's say that we run here where we have all this right starting blank.
Yep.
So we can map something in Freesurfer average. Freesurfer have its own annotation file that theoretically you
Yes.
saying that everything.
Yes.
So what we're saying is that we know based on how we're setting up our regions and things like that to work in
Right.
our own annotation file.
Yes. And you could think of this, you could think of it as just, Freesurfer does this stuff by default. I'll explain that one little wrinkle here that we use as a kind of a cheat to make it easier for us to quickly label the brains and make changes to our labeling system. So it's a little bit different than what Freesurfer does in its normal pipeline. But Freesurfer is doing the same thing. It essentially is, it's using something, well, let me just, all of the stuff is in here, sort of.
I feel like I'm at a good point.
Yeah.
Just wanna make sure.
But we'll catch a bunch of that stuff.
So, I mean, like, this is why I'm just this is why I'm just gonna put the floor on it.
So if we go back to this, I'll go back to this slide here. We'll go back to this image here. So this progression. So just this is like the kind of the overview of the recon all process. So Freesurfer comes packed with this thing, a big ball that's the FS average template, and every vertex on that ball is assigned a value. There's an annotation file. So one thing to keep track of is there are surface files, which are the actual surface of the surface, the vertices. They reflect the surface geometry and the connections between the vertices, right? They are actually, that's this that you get. So you have this surface here, the cyan line, the white matter surface. It looks like that. That gets inflated to a big ball that reflects the geometry of the surface and has information about the curvature of the surface. So the red and green here is denoting surface curvature, but there's an actual structure to this thing that is conserved. So when you go to the ball, we're showing the curvature, but there's a mapping back to its original geometry. What Freesurfer then does is create this mapping between that individual ball and its template ball, this one. So here's the FS average template. It's trying to use the surface curvature and location, relative locations of I guess I would say like where that curvature is, and getting a map between the vertices in this surface to the vertices in this surface. And it ends up, it's interesting because I don't know if this, no, so it creates this warped version that's basically a mapping from the individual space into FS average. So what we now have is a one-to-one. It's actually not even one-to-one. It can be one to more than one mapping from FS average space to or FS average surface to the inflated surface. Now you just take that. You can take that annotation file. So there's this annotation file where that's where.
Sorry. So are you going from the individual surface and then everything into FS average space, taking your FS average space and mapping your instance onto the individual surface?
You go into FS average space. You go into FS average space. Ultimately, any of the things that we're showing you, it's always in the subject's space, but behind the scenes there's this mapping.
So these maps
right.
That you get to it.
Exactly. So you basically have, like, for every point on the FS average surface, you know what the point is on the individual surface. And then, so an annotation file isn't a surface. What it is a list of all the vertices in the surface and then a value. It gives a value to every one of those surfaces. And then, and it also has in it embedded a color table. And that color table links those values to a region. Okay. So we have, say, precentral gyrus. There will be precentral gyrus there will be a value. And usually, with any of these tools, what that is that value is an index in the list, right? So it's like region 3, precentral gyrus. So everywhere, every vertex that would be region 3 would be precentral gyrus. Freesurfer didn't do that. There are reasons to do it, but it did try to create a mess. So instead of it being an index in the color table, it's a combination of the RGB values that you assigned that region. So that part you can choose to ignore that piece of this, and just think of it as a link between a region name, what we want to call it, and some value, some number that's assigned to a vertex. Got it? So think of it like, if when you think of like a labeled volume, right? We take a volume and we say, okay, I have a volume. It's the T1 volume for a subject. I want to label something. I'm going to label every voxel. I'm going to label it. I'm going to give it a label 3, and then I'm going to give it a label 3 if it's in the thalamus. So in that way, you label the thalamus in that volume. So if exactly. That's exactly what this is. It's paint by numbers. And so you can do things like, okay, well, I can label the whole volume. I can give everything in the thalamus a 3, everything in the caudate a 4, everything in motor cortex a 24, and then what the color table does is it says, okay, if it's 24, give it this color value. So literally color it, like say like this here. So each one of these, this is like just some number. This is some number to indicate the different regions. And so you are assigning a color so that you can sort of visually start to tease these things apart. And you also give it a name. You say, okay, number 3, we're going to color that all those voxels green, and we're going to call it thalamus. So the color table is that linking from the value that's assigned to the region label, something useful. And like I was saying before, usually that's fairly simple, where it's either like literally you don't even in the color table, and we can look at a color table. There's no reason I can't show you what these things look like. We'll go back to, I'll show you on there how you can tease this apart. But let's go find a color table. Where am I? Okay, so here's the literal color table that we use for our labeled surfaces, so the annotation files that are generated when we label the brain. Freesurfer, for whatever reason, has a column here of numbers. That's totally redundant, I believe. Well, it's redundant for our purposes because it turns out if you look into the annotation file, some of the literature, there is some, I don't remember what it is, but there is some case where you do want those numbers. But what really matters here is you have, let's say you have anterior insula, and you have this RGB value. This RGB value is essentially the value that's assigned to vertex that is in anterior insula. Let me pick one that's not in on the exterior circle. Go ahead. Yeah. Yes. We can, it's the same. So when I say index, you can use that generally to mean there's a region label and a number next to it. And I'm going to call that the index. In this case, for the annotation files, it does not. It does not.
Hey guys, sorry to interrupt. Could you do you mind changing the microphone settings, because I think the microphone is set to Jason computer and I can only hear Jason, but I have a hard time hearing anybody else. I don't know if you're recording the session, but it's going to be the same issue there.
Yelling. So I guess the way what would be a shame to do is to think about the way Freesurfer does this as like understanding how Freesurfer does this and allowing that to erase what is probably the exact right intuition about how these color tables from just about any other software and brain image display software. Ultimately, they all have different syntax. So Alfonso uses a syntax where he says he doesn't even bother with that list. He uses the index, but he doesn't even bother with this list of numbers because he knows that he just uses the order of the list and says, okay, I'm just going to list the names of the regions, and then when he creates a label volume say, that labeled volume, it has like, it'll have like, okay, there's a region that has a bunch of ones. All the voxels are labeled 1. Well, you when you use the color table, it just looks like, what is the first number in the list, or first region in the list? Oh, it's angular gyrus. Boom. And so, but what Freesurfer did, and I think the reason that Freesurfer did this is that it realized that you might have, people might start using different lists, and what you can't do, and you also have these two different spaces. You're talking about surfaces where you have one precentral gyrus or one motor cortex in that file versus a volume that has left and right. So you have a left motor cortex and a right motor cortex. And what they wanted to do was be able to have those left and rights. They want those to have a unique value. And I think they also realized that people are going to start playing around with this thing. So what they did to, I guess, to expand, I don't know, I'm just speculating why they did this, to expand the number of potential independent regions. So when we do our labeling, we generate these labeled volumes. We use Freesurfer's color table because we combine our surface labels with their subcortical surface labels, and we just add on to it. There's a set of rules for how you create those labels. So we want to basically maintain all these labels that Freesurfer originally has in their color table and add our own. So I believe for that reason, they're anticipating that they, instead of having like a number, some number from 1 to whatever, that, you know, if as the regions expand, if you have enough numbers to go from 1 to 100, well, what if you need 200? Then you got to change stuff. What if you need 1,000? You got to change stuff. So
can I just have you say something?
Alfonso, can you hear me? How about now?
I can hear you better the second time.
Okay, good. All right, great.
When I was debugging the mic this morning, the normal one like wasn't catching anything.
Okay.
So I guess it just took time to warm up.
Great. All right.
Thank you. So yeah, it is. Speak louder.
Well, now it's from here. It was from Jason.
Yeah, because the normal one, like I said, I walked over here to test it and it just couldn't hear me at all. And I was like, sorry to interrupt.
that's all right. I don't know where this is going. So I'll show you another one here too. But basically, the thing to keep, so if I look at this one, I'll take just a quick step back. We have a color table that is associated with our annotation files. And that's what this is. So every region has, this indicates the label. This RGB value ends up, that is actually the indicator. That's the value of the region in the annotation file. And it's not 3 different numbers. What they do is they do this, they get something like R plus this 2 times the G plus the square of B. Something like, it's not, I don't know if it's not exactly, but it's something like that. So they come up with some giant number. And we can even look at those. We can look at some of those if you guys would like. But just think of it as, on that, in the annotation file, every vertex has a number, and then that number points to one of these region labels. And we can look at that here. If I look. Remember when we talked about the interface that there. It's spoiled on large monitors. Okay, so let's say I click on here. This should be middle temporal gyrus, and when I click on it, I go down here and I see PMTG, posterior middle temporal gyrus. And let's see. that vertex value, let's see here. No, I thought it would have the value in the color table, but it doesn't. It just gives you the actual. This could be it, but I don't know that it is. But essentially, each one of these is assigned a number. Let me see here. I don't know for sure that that's what the number is, but I can show you a script. I can show you actually what those numbers end up being, but
That makes sense.
function of those. So that's what you have. You get PMTG here, and then the other kind of color table that we have will behave in the volumes more like what you're thinking anyway. So it still gives a color. There's still a color assigned to each of these. And I believe that color link, so if we take, let's see if we can find one of our anterior insula. Actually, you know what? I don't even know that there's a link here, but when we run a function, I was going to mention that today. There's a function once you generate an annotation, so the labeled surface for an individual, or the labels for an individual surface, you can then map those into the subject's volume space. We've done that, right? We use this function called MRI A part to ASEG. That so when you do that, you then label that volume, but what you're doing is you're moving both ROIs from the left and the right into that same volume. So Freesurfer knows how to take the embedded annotation file, I'm sorry, the embedded color table and that annotation file, and then map that to one of the ROIs in here. And then it generates the labeled volume, and it gives that labeled volume these indices. And let's test this. If I'm telling you the truth, or I'm just making this up. Okay, so left anterior insula. Okay, so if I go here, I'm going to make it smaller, so I'm not going to move this thing around. So I'll reduce and then enlarge. Okay, so this is an actual labeled cortex. So let me just so you get this. So this. Here's the T1 scan, and I have the left peel surface, the left white matter surface, right? And then when we run MRI APARC to ASEG, let me load up one more volume here so I can complete the circle. Okay, so last here. Then I just loaded up Freesurfer's automatic ASEG. And if I click on something in here and I look down at ASEG, I see what the value is.
So that 12, so with the Freesurfer automatic labeling is meaningful?
Let's go look. Let's see what 12 is in here. So this is our color table, but what it should do is preserve what Freesurfer does. So we can use Freesurfer's labels, and then we're just adding, and we're following the set of rules that Freesurfer uses.
Right.
So when this gets mapped, there's no left putamen in our surface ROIs. We're just mapping into the volume with all of our ROIs, and we give them, we come up with a new index here, and if we go back to And there are certain rules where I think it's like subcorticals, segmented subcortical regions are given values up to 100, and then left hemisphere cortical ROIs are given values starting at, I'm sorry, not up to 100, up to 999. Then cortical ROIs start at 1,000 for the left hemisphere, and 2,000 for the right, and 3,000 for the left white matter, 4,000 for the right white matter, and so on. So if we go to back to left anterior insula, 1019. Okay, so what I'm going to do is move this up. So it's at the top. So what appears to happen here, and that's why I kind of hedged a bit before because I wasn't 100% sure, is that the colors are not conserved between these two, but the mapping from a value to a region is conserved. So if I look at anterior insula, and I'll be able to,
Why don't you pick another? Yeah, we can work backwards.
Here we go. Left anterior insula. Okay, so over here it's phase 1019. So this works just like you think. There's a number here, 1019, and that's the value that's assigned in the label volume for left anterior insula.
Can you go back to that image? So it's 1019, and then in the ASEG file, because it's just lumped in with something else because it didn't specifically.
And so that's just, it's just left cerebral cortex.
Okay.
And you can tell, so when you stack these volumes, label volumes, you can use this to see. So here it is, here's the our SLFS average, value 1019, ASEG value is 3. And so having looked at this, I do think that this is probably these down here. So if I go back to this, I can't decide if I think that. I don't think that's actually the color value here, which is unfortunate. I wish we could see that.
The indices are real in the volume, but not on the surface.
That column, yes, that column of indices is real in the volume.
Okay.
In the recon, it's not used. It's not used in terms of like what the actual labels are. It's this function of this. So I think it's something like this plus 2 times this plus the square of this. Doesn't mean something number. And what you have by doing that, you can just create this gigantic set of potential unique values.
I think the rule was treating those RGB values as a base 256 number. So basically multiplies the first by 256 square, and then the second by 256, and the third by 1. I think. Yeah. Because these numbers are always from 0 to 55, each of them, because they are. Yeah.
So that just causes confusion. But there are, so I don't know if it's worth it to like load MATLAB and show you. If you
I think it's okay.
that. So if you, one of the things I did want to tell you about that as I was getting ready for today, I realized that we have these scripts. So I feel like we're at the point where I'm going to talk about a script that opens stuff in preview, and then but we move off. But the color table thing is pretty key because you end up using that. What's convenient is the annotation files. They're just embedded in there. You know, at the very beginning, if you're just creating a labeling system, you need to have that color table, and you say, okay, label these vertices with this, and assign each region a value. But once you've done that, these they're embedded with the volume. That's if we go back to here. With the volume, it's not embedded. That you have to have. It's just a volume with numbers, and every voxel that indicates the value that's associated with a region. You have to supply it with a color table. So when you load let's say you want to load the labeled volume that we generate, you also need to indicate a color table. And when you're using Freesurfer's tools to play around with this stuff and say generate ROIs, you need to be aware of that. And what I've done is for all in our SL ROIs directory, there's a directory called SLFS average, and that's meant to have all the files that we use that are related to our labeled FS average surface template. And then, yeah, so the surface, the labeled SLFS average parcellation. And you can find that color tab in there. One other resource that'll become more and more useful is, hopefully, and I've updated the slides to reflect this. Is a directory in our project Views Lab software directory called FS scripts, Freesurfer scripts, and that's where I'll put scripts that do particular functions that other people will use. If you have some, any like scripts, because we're just currently in the process of expanding what we do with the Freesurfer data. So if you have, like Liz, if you have a script that does a bunch of stuff, toss it in here and give it a label that seems like people can kind of tell what it's going to do. But in these, so here's one script that I was just working on for this. So here's a script that it's actually, there's more to it that needs to be because I modified it on a different script, but it essentially will allow you to load up exactly what we saw in that preview window. It'll load up the volumes that are relevant. It'll load up it'll load up if it's available the annotation files for the surfaces based on some root. So root here would be something like it. So the default is the SLFS average, but if you say you were using one of the different annotations that we have available, like SLFS average 17.19 GUM, you can give it that as an input, and it will then load those all up, and it'll look for a surface or for the label volume if you generated that. If for some reason you're loading up something else and you want to use a different color table, so if you put in so let's say in this case you want to look at one of Freesurfer's default label or annotations, you could give it that root like a part, and you could give it a different volume label color table, and it'll know. So based on the number, I mean, this is not meant to be a super like robust script, but it'll quickly allow you to load these up. And there are some other ones in there that'll load up different subsets of the Freesurfer output. Yeah, and you'll see the Freeview. There are a lot of different flags that you can add to scripts to make them exactly what you want. So if you're quickly wanted to see, okay, these the labels look like this all ran correctly, I'll load them up. And that script was originally C shell script. So the syntax for that would be you have to point to that. What's that?
Sorry, I've been hearing about I've been working with seashells for, I don't know, like almost a decade now. The first time I got that it was a joke.
Okay, so, and just as a throwback here, let me see where the terminal is. So remember, the different things that you want to do every time you're going to look at this is you want to define a subject first. Subjects there equal pointer to your directory, and then what you can do now is you can assign. You can also it's very handy to assign a pointer to scripts. So rather than having just different scripts that you use, like just keep copying them all over the place. I mean, it can be like, sometimes it makes sense to do that because things are highly individualized for a study. But you can point to, say, that directory. Use lab, software, FS scripts, and then you just, in this case, this, and you can change the script. You can make it a bash script if you'd like. G, and that I could just, if I just type in the name of this subject and hit return, it's going to pop up, and I'll do that this time. It'll pop up the default SLFS average label or annotations and label volume. If I did it like I did before, where I type in this alternative, it'll load those up. Okay, so takes some time. So let me see here.
So you probably said this and I missed it, but is there a way to, when you have one of these MGC files containing the parcellation for a given subject, to know which annotation file was used to generate it?
Not directly, no. So what you want, so the way that we are moving here is that the user responsibly assigns it a label that makes sense. So in this case, the actual file is, so it's all the default, and by default it's really, there's nothing that forces it to be this way. You assign these label volumes a name. And what Freesurfer typically does is you're adding your surface-based labels, cortical labels, to the ASEG volume, so it's like something plus ASEG. So Freesurfer's automatic parcellation is APARC, and it creates, by default, an APARC plus ASEG volume. So what we want to do is just be disciplined in using these SLFS average. But the root, I'm calling it, of the parcellation, the annotation that we're using, plus ASEG. You because you can easily, if I were to just change what the lookup table is here, I could just use Freesurfers, and it would be very different. In fact, it would give me a different value for each of, give me a different name. So that I am not aware of a way to embed that information in the volume itself.
Well, we could, if we want to make it like compatible with the way our FL pipeline works, we could just add like a text file with the same name as this MGC file that contains just the labels, just a copy exactly of the text file that has been used to generate the text files containing the list of ROI numbers, ROI names, and RGB values. So basically, just copy the.
Right, that would be very handy.
I don't know. Perhaps we can add it to our like scripts that when it generates these files to generate it with a sidecar like a .txt file that contains a copy of whatever labels were used at that time, because these parcellation files might also change over time, and that makes our job of interpreting these files like considerably harder, because we don't know if we are using the same version of the parcellation file that we have right now, or perhaps when these were generated, they used a different version. So it's, I don't know, having that like copy of the text file that was used to generate the association between the numbers that are in these MGC files that are just ROI indexes and the actual regions that you were meaning to label by those numbers, it would be useful, perhaps.
I think that would be very handy. Otherwise, it's up to the user to point. And the way we're trying to make that, we're trying to make it so that any additions we make to the color table, be it the surface color table or the volume color table, you're not changing anything. Like you're just making additions. Right. So that you can, that color table, that our most recent color table that we're using today, you could load up a labeled volume from 5 years ago, 8 years ago, and it would still assign
the appropriate
correctly. But it would be really handy to have that. Otherwise, you're always having to put in a pointer to another file. It may be that you may be able to have a flag. So it may be that you can assign a flag so that it does generate a C tab for the volume. So it's not embedded in the volume. It would just be a C tab that would have the same name. So I think if you use, I don't know if it's with MR on an A setting, possibly. It may generate that for you.
Great.
With the same name, so we could look into that. But you'd still have to know to link the files. We haven't really done that because we've kind of kept the same one around. But I can look into that. Okay, so really quickly here, I'm going to hold this to right around 11 because everybody's got a lot to be doing here. We've basically been talking about color tables, I guess, most of today, and the fact that you can play around with that script. And I was going to talk about the things in the script a little bit more, but we won't do that. Now, I just want to go into, so when you run recon all, and remember there's this awesome online page here that has all the steps of the recon all. By default, it creates a number of different annotation files reflecting different parcellation systems, and it even creates the labeled volumes based on those.
One question: the annotation files that this pipeline generates, they are all in kind of like the subject space, right? They are not like an FS average, so they contain the same number of vertices as the original parcellation of the brain in the subject, which is not the default number of vertices in FS average. Is that right?
Yep, and that's one thing to keep in mind is that if you all those annotation files are in the individual subject space. You can't directly apply them to, say, the FS average template or any other frame. There's a mapping there. It's a specific.
And is there an option to generate those annotation files in FS average as well, or that's not an option in the recon all pipeline?
I think that. Are you saying the annotation files themselves?
Right, because the annotation is just a list of for every vertex it gives you a number basically that, well, in addition to all of these labels and all of that, but it's basically just a number that identifies that particular vertex which RY it belongs to, but it's listed as many vertices as the raw, like the first tessellation, not the FS average, kind of like resampling of the tessellation. So that's why I was wondering if there is like a second version of the annotation files that could be already containing the number of vertices which match the FS average space rather than the raw tessellation of each subject.
I don't know if that's the case. Yeah, I don't know. I mean, essentially, when you map the individual into the FS average space, the FS average label.
Right, you could use the original annotation file, right, rather than the subject-specific annotation files for that.
Right. Okay. So we need to generate these. We need to generate the annotation files after we run recon and determine if the frame is okay. And we've already kind of gone over this. We've gone over this stuff. And what we can do, and I'm happy to do this too. I mean, I guess there's just like every time we sit and do this, I realize there's a lot more of this than it occurs to me, and how much might be useful to you. But there are MATLAB functions that are now in that FS scripts directory, read annotation, write annotation, where you can actually read an annotation in MATLAB, and it returns like a list of the vertices, a list of the vertex values, and the color table itself. And you can look and see, okay, here's what these values are, and you can play around with that. And we've started using that as a way to label specific ROIs when we're doing search. You can create, modify annotation files, which can be useful at times. I'll just quickly run through this so it's on the record. When you are we generate these label files. There's the annotation file itself. There's a surface color lookup table that we've gone over that it gets embedded into the annotation, and then the volume color lookup table. Talk about that. And when we talk about our annotation files, there are some commonly used ones that are just simply different versions of this labeling system. So here's our full our current parcellation system, and where we subdivide these areas like inferior frontal, gyrus, and over the last few years, well, it's been a bit now, but we've added different ROIs. But so think of this is SLFS average. That's the full, most up-to-date cortical parcellation that we do in the speech lab. We have a few others. So this one that you've seen here, this one that I've also loaded. This is one that Liz has been using for doing her pooled analysis of stuttering data. And this one is also based on the SLFS average, the FS average template. It's essentially a little bit older version of our speech lab annotation, and so it doesn't have all of the regions. There are a few regions that are not there, like this inferior gyrus pars reticulata. and mid SC and cingulate motor areas, but and that's just a reflection of when we started the project. And also is missing these IFO, IFT, so inferior frontal gyrus, circularis, triangularis, missing the subdivisions. And the reason for that is that we found that the reliability of those regions was not very good. So the reliability of the entire inferior frontal gyrus area is not great in Freesurfer, but when you try to subdivide them the way that we were doing it, it wasn't doing a very good job. And we realized, okay, if we're going to do this, we're doing this study with Sue-Ann Chang, and she's going to be collecting a lot of data from a lot of kids, and then she's going to be doing it over 4 time points. We're not going to be able to sit and fix all these, so we wanted to make it as accurate as possible without manual corrections. So we just dumped those subdivisions. So so that's why you have a one IFG here.
That shouldn't be needed for anybody except for this one project where it's comparing, right?
Right,
So
right. It might not be needed, right? Probably wouldn't be needed. There was another one here where it's basically this SLS average, but it also has the IFO and IFT subdivisions removed. Then we have other ones. You can kind of think of this as like lump 0. But then we have these other ones where we lump a bunch of regions. So instead of having a VPMC and a VMC and a mid-PMC and a mid-MC, we have a precentral, like ventral precentral gyrus, and we lump together a bunch of the different major, like a bunch of the gyral subdivisions that there are reasons that we want them and some reasons that we don't want them. So there are a few different versions of this, and all of this stuff is described in this SL ROI Notes Google Doc. So depending on what you're doing, so some of these are for display purposes. You might want to use one of these lumped ones. Some of it's because we don't really have a good sense of how a smaller region, a good hypothesis that would motivate us to want to look at the smaller region. We want to combine them. When we're doing the morphometry, we've been tending to do that, to combine them, because we don't really know we don't really have a good sense of how these align with functional maps, and we're comparing across subjects, and there's a lot of individual variability. So we're worried that if we use ROIs that are too small, that we might be missing an effect because there's a lack of overlap, and you drive that problem up smaller and smaller and smaller. You make these ROIs. So what we want to do going forward is use these. I'll call these the roots, SLFS average, and then this whole thing, the roots. So when you're creating the annotation files, you create those. You give them these root names, and then one more that we might use if you're working on the Chang data set, or potentially any other pediatric data set. We have one that's actually not mapped to the FS average adult template. It's mapped to a template of kids that was generated from kids that we generated from our sample, and that's this mixed 7x7 template. So if we're in a position where we need to label these brains, we're going to use that, and we can all, and so you can create these different templates. So you can create these different. We can label them all, and just as one final thing, and then next time we'll go into actually extracting the data, and there are a few other common things that we do with these files, is that the way that we label these is we take the label template and we just map that, or we just use the mapping from that label template to the individual surface and assign an index, or assign a value to each vertex that indicates the region that we want. But if you do some, if you look into Freesurfer at all, or if you just go back and look and you're paying attention, you see that there's no MRI surf to surf in this in this table of the steps to become all. Instead, what they use is this function MRISCA label. And what they do is they apply a classifier, a probabilistic atlas of the regions that's been built up from a bunch of individual subjects that were labeled and manually corrected. So they use that classifier to generate those A-part, whatever, annotations. So, so if you said, hey, well, I thought Freesurfer used a classifier, you were correct. It does use that classifier. And it turns out that you can make your own classifier, and we did that. That's where this all comes from. So the 17 here, when you see the number 17, that's where this comes from, because we manually labeled 17 brains, created our own classifier. And so the original speech lab labels, there was a certain parcellation system at that time. We applied that using classifier, but then we realized, well, what happens when you want to change that labeling system? What if you want to add new regions? What if you want to subdivide our area into subunits? In order to do that and use Freesurfer's classifier labeling capability, you need to edit every single brain that's in the data set, which takes a fair amount of time. So what we did was a while ago, we said, well, what if we just label them, if we just map from the template surface to the individuals, let's do that, and then compare how those look versus using the classifier. And what we found is that they look very similar. Very similar. They probably are similar enough that the two things are equivalent. And I've talked with the people at Freesurfer, and I thought they were going to say, well, no, here's the interesting thing that you're going to miss. If you do it that way, I said, yeah, that makes sense, because that mapping from FS average to the individual surface takes into account a lot of the same things that the classifier is trying to take into account: surface curvature and relative distances between vertices, like the likelihood that the relative distance between vertices with respect to that curvature. So it seems like that works. It works sufficiently, and that allows us to, on the fly, make changes to our parcellation system. And it allows us to do something like have our functional ROIs, where that has nothing, ultimately, yes, those ROIs are on a template, an anatomical surface. There's a relationship between where they are and the surface, but it's nothing that we could go in and fix. It is what it is. But we can take that, use that, and apply that to brains in a very straightforward manner using MRI surface. So, okay, I'll stop there. So next time is to go over common steps.